Okay, some hints to consider if you haven't already figured out how to solve this model. First of all, we have a fixed number of pallets circulating in the system, and so you can see the previous video where we solved this exact same problem. The only difference was in the previous video we specified how many we wanted, and in this case we have to use a reference property so that you can manipulate, so that you can experiment with that value. Use a time path for pallet recirculation since you're given a fixed time for recirculation. So as I mentioned, reference properties, we have two decision variables, the number of pallets and the pallet capacities. So we want each of those to be a reference property so that they then become experimental controls. Next, we want to create an output statistic for total cost. This one's actually an optional inclusion because we can see the same thing as an experimental response, which I have here. So for the experimental responses, we want to have the throughput and the average time in system because both of these are constrained. We have a minimum throughput requirement and we have a maximum average time in system requirement. So we want experimental responses so that we can ensure that the particular configuration that we're experimenting with meets those considerations. And then we also want cost just so that we can see what the cost of the solution is so that we can pick the maximum value. And the last hint has to do with calculating the processing time. Recall that the processing time is for each part is exponentially distributed with a mean of 0.9. And so you might think that a function we could use or an expression we could use is as follows. We could use random.exponential 0.9 times the pallet capacity, and that lets you define the pallet capacity as a variable and then multiply to get, for each part. But that doesn't really work because this expression incorporates too many extreme values, because what we really need to do is we need to sample from the exponential distribution for each part. And so if we three different ways to do that. One is we could just sum them. So we have expo 0.9 plus expo 0.9 plus expo 0.9 and so on. This is a bit difficult for our problem because the number of parts on the pallet is a decision variable. So you could do this with an add-on process, but it gets a bit involved. Secondly, we could use an Erlang distribution, which exactly models this, the sum of exponential. And so if you use an Erlang distribution with the 0.9 and the pallet capacity, you will sample correctly. Or we can use math sum of samples, and so the sum of samples will essentially take the specified number of samples from the distribution and sum those up. So you're going to have to use one of these methods in order to correctly model the processing time for the pallet. So now you should stop the video and try to do the workshop.